Hi, my name is Hunter Levinson, and this is my Physics 2212 lab report on tape. The purpose of this lab is to determine the charges between two charged Scotch tapes, tape A and tape B, and this experiment will be conducted by putting B, resting it across two shelves and dangling tape A beneath it and seeing the displacement of tape B. What's important to know about this lab is that we're going to be treating both tapes as point charges for calculations, and we know that like charges repel, which gives us this this image right here and what really happens. And we'll go into that in more detail later. The important equations to know are Coulomb's law, which states that the force of a charge on another charge, especially if those two charges are the same charge, which they are in this experiment, is the charges squared multiplied by Coulomb's constant divided by the distance between those charges squared. The force of gravity is also important, which is just equal to mass times the force of gravity, or mass times the gravitational component, which is 9.81 meters per second squared. Our experiment procedure was taking both tapes A and B, represented by the U tape in this image, and ripping them off of a base tape. Then we need to determine what their charge was. So we dangle them near neutral objects, and they were attracted to the neutral object, which makes sense because of induced dipoles, where the charged object will separate the charges in the neutral object, making the neutral object attracted. Then we put the tapes next to a charged pen, a negatively charged pen, and they were attracted, which means that the tape was positively charged. And finally, tapes A and B repelled each other, which means that they were both positively charged. We know that oppositely charged objects repel each other, so or oppositely charged objects attract each other, and similarly charged objects repel each other. The initial values for our experiment, as you can see, the tape dimensions, and we knew that the tape mass going into the experiment was 1 gram per meter squared, or 0.001 kilograms per meter squared, which gave us the tape mass. And then we saw that tape B had a displacement, the point particles had a displacement of 0.01 meters. Using the two force equations, Coulomb's law and the gravitational force equation, and setting them equal to each other, which we did because the object was floating, so these forces must have been equal. And solving for the charge, we got that the charge was 4.669 times 10 to the negative 9 coulombs. Some assumptions was that the U tape had the same net charge, which meant that we could make it Q squared, and that the electrons were evenly distributed. All of the surface area of tape is affected by the charge, and that the tape can be treated as a point charge, as I discussed earlier. For the electron deficiency, we took the charge that we got in the previous equation and multiplied it by 1 over the charge per electron to get the total number of electrons that must have been involved in getting that charge. And that number was 2.92 times 10 to the 10th electrons. And we know that it's a deficiency because both of the tapes have a positive charge. The atom ratio, using the atom length scale squared, and the tape area, which we got by multiplying the length by the width, and we're assuming that the height is just 1 electron. And so dividing the tape area by the atom length scale squared will give us the total atoms, or the surface area divided by atoms per surface area, which is, or surface area per atoms, which is just going to give us the total number of atoms, and that is 4 times 10 to the 17th atoms. So then doing a ratio between the two of electron deficiency and atoms, we got that there are 1.37 times 10 to the 7th atoms for every electron on one piece of tape. Here is my code. As you can see, the green arrow going down represents gravity, and the up arrow represents the electron charge, and all the calculated values match the results that I got from my calculations. My sources of error was that we assumed that the tape is 1 atom thick, that the charges were clearly not evenly distributed, and that the charge might have been interrupted during handling, like we talked about, due to the induced cycles. Our what ifs, the what if we saw that there would not be that big of a difference, there'd be similar calculations, although it would be a proton deficiency. And the why is that it's important in not handling because of the induced cycles, like we talked about before. Thank you.